everyone. My name is Brianna Curl, and I will be your moderator for today's webinar on Flex PCB Design Guidelines for Manufacturing. If you have any questions throughout the webinar, please type them in the questions panel as they come up. We will have representatives ready to answer your questions directly during the webinar. Today's webinar is hosted by EMA Design Automation and Sierra Circuit. EMA Design Automation is a leader in product development solutions, offering a complete range of electrical and mechanical CAD tools, along with much more. Sierra Circuits has 30+ years of PCB manufacturing and assembly experience, which has made them the trusted source for end-to-end PCB prototypes. With that being said, I want to thank you all for joining us for today's webinar and introduce you to our presenters, Amit Ball and Janine Flagg. Amit has been in the PCB industry for 20 years. He is the Director of Sales and Marketing at Sierra Circuits. His passion is to empower tech companies to achieve their visions and change the world. Janine Flagg has worked with the Cadence tools as an application engineer and as an end user for over 20 years. She specializes in the front-to-back flow and supports both the OrCAD and Allegro products. With that being said, I want to pass it on over to Amit, and thank you.
Thank you so much, Brianna. Thank you, everybody, for attending. If there are any problems with my audio, just chat with me so I can fix them. And we have a lot to talk about in this webinar, so let's get started. That's my pretty picture and Janine's pretty picture. So here's the table of contents. Why Flex anyways? What is the point of Flex? Why should we care about Flex? Well, I'll tell you, Flex is really growing, and it has been growing for the last 5 to 10 years. So if you look at all the different types of PCB technologies, HDI, Flex, special materials, fine lines, from our standpoint, Flex has been growing the most. And if you look at the IPC industry surveys, it's also growing a lot. So if you don't have knowledge of Flex, then you could be missing out on some key advantages. So number one advantage is that you could have a possible cost reduction looking at a total systems cost. Of course, if you look at just the cost of a rigid Flex PCB as an example, it will be more than its counterpart of a rigid PCB. But if you look at the total install cost, it will be less expensive. And it also adds quality and reliability to your end product. So in terms of how to use and the ease of use and the benefits, I think the key point is the reduction of failures in the PCB. So it's, solder joint, every solder joint is a source of failure, as the saying goes, it's true. And so you want to make sure that, in your connectors, let's say, you could possibly eliminate some connectors and, use rigid Flex instead, and that would eliminate potential failure points. And then, of course, when you're dealing with very intricate mechanical designs, a Flex or a rigid Flex really allows you to miniaturize the electronics and fit things into a tight space. So it's always about form, fit, and function when you talk about Flex and rigid Flex. I mentioned possible cost reduction. So just understand there's direct and indirect costs when you're looking at Flex. So my advice is don't have the supply chain people make the decisions on this technology, but as engineers, you should make the decisions on what technologies go into your product so you can have a better product. And then for Flex and rigid Flex, there's always static and dynamic applications. So be aware of which application you are going to be using, and just be aware that even if it's a bend to install, people will flex that board. It flexes in the PCB fabrication area, the assembly area. It will flex when it comes to you. Your internal quality teams, they'll start flexing it. So there's never really a one-time flex. It's still always many flexes. Okay, so I think these are the key points in understanding, saying that you have a good understanding of Flex. Understanding, of course, how the board will bend, understanding a little bit about the materials, how you route, which Janine will go into later. All that's really important. I think bend radius is super important. So for a bend radius, you basically, it's the minimum amount of bend basically that you can deal with. So you want to make sure that you understand how many copper layers you have in your flex region that would then have to bend. So that's a super important point to be able to calculate your bend radius. And IPC 2223 specifies the standards of the bend radius. So take a look at that. If you have a multi-layer board, flex board, at least the flex section of the rigid flex board, you need to really consider the flex thickness times, probably about 15 is your minimum bend radius. It says 24, but there's some leeway there. Now, really important is understanding and sharing the understanding with the fabricator on what are the flex regions and what are the rigid regions in a rigid flex application. So always have like a drawing that's really specifies out, all these details. So that way your manufacturer can give as much guidance as possible. So these are some general guidelines when designing flex and rigid flex. So you want to avoid your 90-degree bends. You definitely want to have higher thresholds, or you're in your design rules. You want everything to be as loose as possible because there's a lot of variation when you're doing flex and rigid flex. You definitely don't want plated holes in your flex area if you can avoid them. You also don't want components in your flex area if you can avoid them, because those all can lead to failures at the solder joints. So in terms of knowing your flex materials, there's really adhesive-based and adhesive-less. And so I'm a proponent of adhesive-less because I've seen many instances where adhesive, although sometimes necessary, is a root cause for failure. And so there's things you can do in this type of a material, like that prevents it makes a more robust design, but it's still going to be an issue probably. So one example of something you can do is not drill any less than a 10 mil via if you have adhesive materials in your stack up. I guess it's always good to scare people. So you can have, cracks both in copper and in laminate. So just know exactly what materials you're using and why. And so kind of these are all of flex materials kind of fall into these categories. And we primarily use DuPont flex material. And I think most manufacturers in the United States use DuPont. So the AP refers to core, and LF refers to, bond plies and such.